Hello and welcome back. In this session, we are going to learn hash table implementation, design as well as implementation using Python. Here is the problem description. Maximizing it. Okay. So problem statement: design a hash map without using any built-in hash table library, and there are a few constants that we need to follow, or a few rules we need to follow, or that is something that we need to implement. One is we're implementing a put method, and that takes key and value, and this basically inserts both key as well as value, and in a like they stay in a mapped context, map. They are mapped when they are inserted. They should be in a mapped position. That meaning when I try to access value corresponding to a corresponding to a key, I should be able to do that. Okay, and then next one is get key. Get, and then parameter is key. If I pass key, I should be able to get a value. And then third one, remove key. If I pass key, I should be able to remove the both entire mapping, key as well as value. Not the all mappings, but the uh, key and its value, that mapping. Not only just removes the value, it removes the value. It also removes the key. That means it removes the mapping between that particular key and value. Okay. All right, so once we implement, here is the test that we need to do. Okay, we create a HashMap, and we're going to keep the same name in Python as well. And then we we put like a couple of key value pairs, and then we try to get based on the key. And we also try to get, like, for 15, there is no key that we inserted, and we expect -1. And we update another, like line number 16, put 10 5. We are updating the key 10 with value 5. That previous 10 will be overwritten. In line number 13, key is also 10, value is also 10, so it might be confusing, but we're referring the value. Okay, that 10 value is the second parameter, that tuple or pair, you could say, is replaced by 5 here in line number 16. Okay, and then we try to get 10 at that time. This time we need to get, we should get 5 because we just updated with the value with 5. Okay, and then we remove that key value mapping, and then once we remove again, we try to get it back. Since it doesn't exist, it's written -1, right? And there are certain things that we follow. Line number 22, we have a range for key and values. Okay, 0 to that's 1 million. And then line number 23, the number of operations should be in the range of 0 to 10,000. And then we are not allowed to use built-in HashMap library. Okay, and complexity analysis, let's quickly go through it. Time complexity, order of n divided by k. Because well, first let's see where n is the number of all possible keys. Okay, n is the keys, and k is the number of predefined buckets. Okay, key divided by buckets. What does it give us? Key divided by buckets. So each bucket has certain number of keys, right? So that means it gives us um, predefined number. Okay, k is the number of predefined buckets in the hash map. Okay, so total keys divided by the buckets, that gives it the bucket size, basically, so that's why, because it takes time to yeah, buck divided by the, yeah, k is the number of predefined buckets. Okay, that's the bucket number. If we divide the key by the bucket number, then we get the bucket size. So that's the time it takes to traverse, so basically, yeah, basically, with the hash key, we look at the bucket in order of 1. So that's order of 1, so we don't have to bother about that. What is the bucket size? Yeah. So, and space complexity, order of k plus m. K is again the predefined number. That's buckets, number of buckets, and then we have m, space complexity. So yeah, so all the buckets, and then number of buckets, those many buckets, and then where k is the number of, yeah, buckets, and then m is the number of unique keys that have been inserted. Okay, why is that? Because it could be that it could be that uh, for the you know if I want to well, basically this gives the total storage actually, required, because we have k number of buckets, and then we have, in those k number of buckets, we have m number of already inserted things, so that's the space occupied, right? So that's why the space complexity. All right, let's go to our Python implementation. Since the program is a little bit longer, again, like in Java, for this also I typed it beforehand, so that we could just go through it now, and then that will help me to reduce the video size, so that I can upload into different platforms. All right, I already have it set here. Okay, my HashMap app.py. Okay, let's activate the line numbers. Number. Okay, uh, we have line numbers activated, and now let's go from top to bottom, and then once we analyze it, we will run the program and make sure that it actually works. We're not just kind of typing a bunch of things that doesn't work. We're actually doing the real programming. All right, so if you remember in Java, or if you got a chance to see Java implementation, we had a pair class there, right? That pair had something called first and then second, two fields, first for key, second for value. But here we didn't need that because Python allows us to extract key value easily. Okay, that's a pair, so we didn't need to create another class here. So we only have two classes, one for bucket and another for my HashMap. Bucket is more like a inner implementation, because in my HashMap I have a bunch of buckets, right? So I need to have that kind of thing. All right, so it's a class, so it has a init method here in line number 2, and it doesn't take any parameter, but this self is to indicate that this is the this is basically a constructor. So in if you have a class, and constructor is also kind of kind of method in object oriented, if you see from object oriented perspective, and it doesn't have parameter, and self is to indicate that it is a class member, meaning it's a method. Okay, so self.bucket is equal to empty. Okay, that's an empty array. Array and list are same in Python. So we have, and then I didn't have to necessarily define this bucket, declare this bucket before I use it here. Basically, if you have something in the init new name, that's automatically understood by the Python interpreter that this is a class variable. Okay, like in Java, I didn't have to necessarily declare that beforehand along with the type. Okay, and type it in for based on what is being assigned to it for the first time. All right, so next is get. So get, obviously, if you pass, note that in Python, the class members, like per method, let's say method now onwards, we have self, self, self. It's very easy. That means those are methods. If we remove the self, it could be function, right? Yeah, but this is inside the class. Okay, in the get we pass key, and then we get the value associated with that key. So we iterate, okay, for, and then we say kv. I can have a space here, okay, for kv. I'm gonna write that for kv. So we're expecting a tuple, a pair or tuple in self.bucket. Okay, so bucket contains will be see the insertion below line number 19. If you see self bucket append key value, so insert the tuple, so that means we are able to extract tuple as well. So kv key value in self bucket, it keeps iterating, and we compare if the key for that tuple, current tuple, that equals to the past parameter value, that means we found it and we return v, otherwise we return -1. Okay, and in update we pass the key value. If it already exists, then we update the value. If it doesn't exist, then we append. Okay, so found for we set to false, and again for for ki and kv. So this I here is a loop iteration variable, and then kv is actually the element that comes out of by enumerating bucket. Okay, so kv contains the tuple actually. Okay, so if if key is equal to kv0, so kv0 gives us the key. If key past key value is equal to in the if you find that in the while iterating in the bucket, that means um, uh, self bucket I is equal to key value. We assign both key and value. You know, it key is already found, and then it doesn't update key, but it will update the value if the value is different. If it's the same thing, it will not update. Okay, because it doesn't have to update. And found is equal to true. So found is equal to true because we found if k is equal to kv0, is matching, right? And then we come out of it because we're done. If not found, if that value, because c is false here, it is not set true if it's not found. If not found, then what we do is we just append the key value pair, and then remove, we pass the key, we iterate again, we iterate uh, this way, slightly different, we're using enumerate, and I is the loop control variable, whereas kv is the element, the tuple that comes out of the every iteration. It has key and value, and then we compare. The past key is equal to first element of that tuple. If that's true, that means we can delete that because it's a remove, right? Delete cell bucket 0. So there is a delete available. Okay, so now it's a fairly uh, easy, and we have next class which my HashMap, and we have a object. This object means we're not really extending any other class hierarchy or anything. It's just okay, we're going to construct everything here. So now since this is a class, we have init in itself. It also doesn't have any parameters other than telling that it is a self indicates that it is a class member or method, and we have two class variables here. Okay, these are in the constructor because init is a constructor. Key space, that's a predefined value. We chose this particular number. We could choose another number as well. And then hash table. What do you do in hash table? We create an array or list, whatever you want to call. We create an instance of bucket. How many times? For we execute this is like executing this statement for how many times? For I in range self key space 2069 times we execute that. We create that all the buckets. Okay, so buckets are available now. Okay, initialization, this is empty initialization, empty buckets are created, and then when we insert value, we'll go to those buckets. Put, so input we collect key value. So interesting thing here is we have to get the hash key. Why do you need the hash key? Because that's how we determine which bucket we have to go to. Okay, so here is our typical formula or little algorithm. You could say formula rather than algorithm because it's just one step. Key, whatever key is being passed in that key value pair over here in line number 31, key mode self key space. The remainder gives us the hash key. Okay, so that's the tag. That's the tag we'll go with. Okay, and that remainder will go and get the from hash table. We created that container here. From that hash table, we using hash key. We get that particular bucket, and that bucket's type is capital B bucket, that class, and there's a bunch of methods. The update is one of them, right? So if we update, if it already exists, key value doesn't have to be changed. If it doesn't exist, it will just append that. Similarly, for get, we only have to pass key. Again, hash key has to be calculated, and it's the same thing. Okay, key mode, key space, and with that hash key, we can go to the hash table, this container, and then because it has a bunch of buckets there, and we go to the right bucket by passing the hash key, and then get the key from there. Okay. Similarly for remove, hash key, uh, we again get the hash key, and then we get the bucket by passing the hash key in the hash table, and then we remove. We call the remove method because it has a remove. If we go back here, it has the remove, it deletes, right? And then over here in the update, it does append if it was found. If it's found, it doesn't have to do anything. In the get, if it gets, it returns the value. If it doesn't get, it returns -1. Okay, it's just a bit hidden there because we're calling those methods here. So in get, in what is get here? Okay, so you don't see -1 here because we're calling the buckets method, right? So that's okay. So it's easy, very easy. Now in the main, we create the instance of my HashMap because that's the one that that's our higher level HashMap implementation, even though it has a bucket inside, which it's supposed to have, obviously. That's how HashMap works. And then we put a couple of pairs, 5 key 5 value, 10 key 10 value. We get 5. This will give us get 5. This will give us 5 because the value is also 5. Okay, and then put a new line. Well, we may not need a new line, if it gives a new line already, because well, that's okay. We can have 2 new lines. That's okay. That's fine. It's not very important for it. That's not part of our algorithm. And then HashMap get 15. That will give us -1 because 15 we have not inserted. There is no key with that value. I mean, there is no key with key value 15, so we get -1. And then we this put will update that whatever was executed in line number 46 is going to insert value 10. Is going to update or override that value 10 with 5. Okay, and then if you say get 10 here, we'll get 5. Okay, and then we remove that, and then we try to get remove that key. When the key is removed, key value both pair is removed, and then if you try to get it back, we'll get -1. Okay, so that's it. And the last 2 lines are just a typical way to call our main function. Let's call them function because it's outside the class now, right? You could also say in some languages they are used interchangeably. Okay, so last 2 lines, they don't need description because we are seeing it in name matches main, then call the main, and main calls all the rest of the things. Okay, so we're going to quit. We don't have anything to set because we use the pre-typed and per-list program. Now we're going to just run it. Okay, python my HashMap app .py. Okay, run. Is the output 5 -1 5 -1, right? 5 -1 5 -1. Okay, why did we get that? 5 -1 5 -1. If you go back, if I set the number, okay, I'm giving you in case if you didn't have I didn't have enough chance to see the code. I'll just kind of stay here so that you can I'll just here so that you can do well, you could also pause the video and then just if you have to kind of see the code and do typing or anything, you can do that. So we got a 5 from line number 47, and then line number 49 gave us -1 because key doesn't exist, and then line number 52 gave us 5 because we updated the value 10 with 5, and then line number 55 give us -1 because we removed that key value combination, right? So yeah, so this completes our implementation of HashMap in Python.